Good morning, sir.
Good morning, Shivam.
Sir, I have a doubt. Can I just share my screen?
Yes, you can now do it. No problem. 3 minutes, please.
Sir, the host has disabled the screen sharing. Can you
Sir,
please-
immediately doing. Yes, now it is possible.
Okay, sir. There is my screen visible.
Yes.
Sir, I have written a small code related to fork. Sir, but this is not printing what you had taught in the class.
That is ABC PQ or ABC PQR. Two things displayed. Is it correct?
Sir, can you repeat?
ABC PQR and also ABC PQR.
Yes, sir. It is
ABC displayed 2 times. Run it. ABC is displaying 2 times.
Yes, sir. That is my doubt.
Very nice. Okay. Actually, that is not our what you understand. That is the problem. The problem is, have you remember any lined buffer? I told sometimes lined buffer.
No, sir, I don't remember.
So for slash n after a line is
that is
full, it is flash.
when first printf is executed by which process? P1. Yes or no?
Yes, sir.
Code in the buffer first. From the buffer, it will go to the monitor. That you have studied or not?
Okay. Yes, sir. Yes, sir.
So what happened when you send it to the ABC to the monitor? Actually, it is stored in the buffer. It has not flush, and immediately a new process has created, and that process also takes its address space. So all related things has to be copied there also. So when the next process try to display, so both of them will be display PQ1. That's correct. But previously, for the P1 process, ABC has not yet flushed. So ABC is still there in the buffer. So what the second process will do, also get that ABC in the buffer when it is address space copied. So that ABC and this PQR both will be displayed. Then what to do, how to avoid this? You after ABC, you write a slash n. Okay, just write after ABC, write a slash n. Now you run ABC once, PQR has to be 2 times. PQR you put a slash n. Always when you write a printf, put a slash n, it will be faster. So
Sir, I have to put slash n in the line number 9.
no, there. That is important. Second one, PQR, okay. Run it now.
Yes, sir. ABC.
Yes,
URL.
ABC PQR and one more PQR. Because after that process completed, it is. Got it now?
Yes.
Understood?
Yes.
Now you know the importance of what is a lined buffer. जब तक हम नहीं बचेंगे, अगर कोई बोलता if the same thing one is doing by a stderr, जाइए सब लोग तो है, देख पाएंगे. Others also participate. Go to your program, don't change it. Go to your program, please.
Should I share again?
Share no, so that you learn all. Go to the program. What you can do now, instead of a printf, fprintf, right? fprintf. And before ABC, no, before ABC, you write std out, comma. After std out, comma. Then in the that printf also you write a printf. That is not required. From there you remove the slash n.
Okay, sir.
On the top, okay. Change it. You change it slash n and below PQR. नहीं तो पता नहीं चलेगा ना हम लोग को. And वो slash n को भी हटा दीजिए. Very nice. Now you run this program. Only GCC and this OS.c. That's
we don't.
no. Error out will be created. OS.c. Dot slash error out.
ABCPQR, ABCP.
This is ABCPQ or ABCPQ because you are sending it to whom? STD out. STD out means standard output device is your monitor which is maintaining a buffer. Instead of that, you write down STD ERR. Go there. Now,
Sir, I have written this.
instead of STD out, make it to STD ERR.
Both places.
Both not necessary. The first one is sufficient. Now you do it. No. Got it? Getting the things?
Yes, sir.
We have not used a slash n. But what happened now? It is not sending this ABC to the output devices, rather to error devices. And we have studied when something is sent to the error devices doesn't maintain a buffer. It's directly print whatever you say.
Yes, sir.
Okay. So that's the reason now ABC displayed by whom? Only displayed by P1.
Yes, sir.
It is not present in the buffer. Then a P2 has created. And both P1 and the P2 has to be displayed PQ1, that you know. Got it? Yes, that is the importance of it. Thank you. Okay, so we'll start. So last class, very important one we have studied, that how to use the thread programming, because I told that when you go for the gaming kind of a software, when you're making, the thread plays a very important role. Because instead of making a process, because process is a heavyweight as you have studied. Why? Because for every process when you are creating through fork, it is occupy the whole address space. Means the parent's address space will be copied to a child address space, and both parent and a child have their independent address space. But in case of your thread, what the thread says, every thread is using the parent's address space. So that's why we have studied that if P1 is the process and the T1 and the T2 are the two threads, instead of the T1 and the T2 has their own address space like P1, rather both T1 and the T2 use the address space of the P1. So that's why, since the address space consists of any data segment and a code segment, both T1 and the T2 are going to use the same one. If it is the same one, means since it is a global variable present in the P1, then P1's global variable will be used by the T1 also as well as by the T2. So what happens now? If T1 has incremented this global variable to +1, if earlier the global variable A value becomes 5 and the T2 wants to read this data, then obviously it will get the 6, because this is the same area which is used by both T1 and T2. That is very, very interesting part. And what you have observed in this code, in every language, when you implement a thread, the thread is actually a lightweight process. And what is the lightweight? Because he has no own address space, rather it is using a address space of the parent. And another definition of the thread is, you can say it is called as, a thread is called as, then we'll see some example. The thread is a single sequential execution stream within a process. Very important part is, what is a single sequential execution stream? What does it mean? Because as I told in the last class, whenever you want to use a thread, for every thread one function gets assigned, and that function is my single sequential execution stream within the process. It is not a normal function, although it is a normal function, but when you call this normal function, we know that after the function completion, then my control come back to the place where it has called. But in case of a thread, this function itself is the working part of this thread. So once you call a thread, since it is acted like a process, this process executed and never returned back to this place. In the same manner, when another thread created, for him also the same work, that is F1, and once this F1 gets completed, it is not going back. But think about this F1, the same F1 used here, the same F1 used here, the same F1 is also used here, because F1 is a function belongs to this program. But this function is not as acting as a thread's work, rather it is a normal function call. When you make a normal function call, the next statement will never start unless until this function gets completed. But in this case, it will just call a thread, start executing, and immediately my control comes to this place. Again, next thread start, again control come to this place. Means we have now three processes. P1 processes, which is standing here, P2 and P3, which is standing here. And if my F1 is using a global variable called as K, then the K is also used by T1, K is also used by T2, and this function which is now currently called by the P1, that is also used the same K. Means K is a common variable which is used by all. So that at a time, three independent processes are running simultaneously, you can say. Yes, but everything has a address space, but as for this thread case, the P1 has address space and the T1 and the T2 does not have a own address space, rather than using. Now the question comes that if T1 and the T2 are two threads which is acting like a process, is there any separate program counter kind of things are required or not required?
It's required.
Required? Why? Somebody has to answer.
Because they
Yes,
are acting
because-
like different processes.
Very nice. Very nice. Because when assume that it is a P1 process, P1 has this, here you have a created thread. I'll show you an example, just you have to wait. I create a thread by calling this is F1. And there is another function, I create a thread and calling like F2. And think that it is a F1 and think that it is a, here there is a int a equal to 10 and a plus plus and do something. And there is a F2 also where you have a declare a int c equal to 5 and c minus minus and do something. And there is also a variable called as a int p equal to 7 and here you are making a p minus minus and p plus plus, some kind of things you are doing it. Now consider when first line executed, the p has a local variable to him. Then F1 is created, create a thread. So this thread will call this F1 and immediately control comes to this place. Means you have now two places. P1 is here and T1 is here. Again, this P1 calls another thread, that is the T2. So this calls this one. And here the T2 is standing. Now you have a P1 is standing here, T1 is standing here, and T2 is standing here. And you know, T1's job is to execute this line, T2's job is to execute this line, P1's job is to execute this line. Means for these three processes, three different PCs are necessary. Program counters are necessary. And at the same time, is there any start kind of things are necessary for each individual one?
No.
Yes. Why? See, these local variables are going to present in which place?
Sir, what you have just told, that start.
Start, STS.
Stack. Oh.
सर बट
Is
थ्रेड
it
तो
necessary
एड्रेस
for-
का एड्रेस
हाँ?
सर थ्रेड्स
different.
तो पेरेंट का एड्रेस स्पेस लेते हैं तो उनका सेल्फ स्टैक क्यों बनेगा सर?
Self-track क्यों बनेगा? देखिए, very nice. When we are using this particular function P, इसका जो स्टैक जितना ग्रो किया होगा up to this, can this F1 and F2 when it is called by T1 and T2, is it maintaining in the same stack or it has to be separate? It has to be separate. What is the reason? The reason is
ये
because-
local memory.
variables which has to be stored separately or with this main process. It has to be separate stack. Okay, so that's why what they're saying, every thread has their PC, has their own stack. Yes, and second, is there any CPU state necessary for this thread, this thread, this thread?
Yes, sir.
Yes, because he is computing some A++. Same A++ may be computed by this fellow, but his input may be different from his input. Means when the context switching takes place from the P1 to T1 to T2 to P1 to T1 to T2 like this, that time the data belongs to the T1, data belongs to the T2, data belongs to the P1, which is stored inside the register. That will be vary from 3 different processes or not. Correct or not? Because he is handling with 10, he is handling with 5, he is handling with some 7. Means while he is executing this A++, his registers will be stored with some 10 and something kind of things. When he is handling this, his registers are stored with some 5 kind of things. When he is using P++, P minus, then his register will be separately stored. Means you can say his CPU state is also different. Means every thread has basically these things. Yes, he has their own PC because he knows whether he is executing this line, he knows whether he is executing this line, he knows whether it is executing this line or this line. Means my program counter for 3 things will be different. Means for each thread and the process. On stack, I told the F1 may call F2, F1 may use a local variable. So whatever the stack is using, this stack will be different and this stack will be different. Similarly, since they are doing any computation and all are different, so CPU state has to be also different. But few things like you can say, sir, heap area kahan se le raha hai? Main process. Sir, global variable where it is taking? Main processes. And core segment from where it is taking? Main processes. One can ask, sir, why core segment from the main processes? Because we know, sir, this F1 and F2 are the normal functions. I can also call like this. Then do you think that the core segment related to the F1 will be different from the core segment related to this F1 and this F1? Never same. Means, why don't this P1 and a T1 and a T2 should use this core segment of the parent processes? So that's, you can find the core segment will be same, data segment will be same, but the stack and other things will be different. These stacks are different. And the heap area is also used by here. Okay? Yes, ask.
Sir, but
Yes, question.
the water.
No, not getting. Whenever you will think, you can ask. No problem. Anybody has any question related to this? If you have understood a little bit.
Yes, sir, I have one doubt.
Oh, yes, please ask. Please.
So, as you said that threads have their own stack, sir,
Huh?
so their stack will be inside their parent address space stack area only, right?
Very nice, very nice. That you have to learn. That after some time I'll tell you. When I'll tell you there are how many types of threads are there. Only another 5 minutes. Okay. Any other question related?
Sir, that stack which we are creating, which are different to the parent, sir, it must be stored somewhere else now, so that we can access it, not in the parent.
Not in the parent. Not in the parent. But what he is saying, can it is manage all the stacks will be put in the area where the stack area gets allocated? His point, Shivan's point was that one. Means he is not creating a different area. The area is same, but they have segregated it. This stack, this area is used by the P1 stack. This area is used by the P2 stack. This area will be used by the T1 stack. Like this, he is saying. Okay? But the stacks are different. Without
Sir,
stack.
but sir, if we are placing the sir, but if we are dividing the stack of the parent, sir, then gradually it will decrease in a size.
Yes,
Which we
obviously
can
it has
add.
to be decreased. It has to be decreased. It has to be decreased. Gradually your stack size is going to be decreased. That's fine. Yes, since you have a lot of stack area, that's why they can manage with this. But in some cases, his stack will be created not in this general stack, rather in the heap area. I'll come to that point. You have to wait for a minute. I'll just run few programs related to this so that I had already written. There's the reason. I'll just, where is my programs? So let's take study material. Is OS programs threads. One thread program, I'll take it. We'll make a copy. Control save as. Then we'll make thread 1. Then save. Okay. No, cancel. We'll make thread 3. Yes. So let's see one small thread program from here. So what you have to basically do? We want to create the threads, and how you are creating a thread. So this is a complicated code. Yes. So let's take this is a function. That is a F1 function. This F1 function's job is to display certain things. And how to create a thread? There is a parameter called as a p thread. T. POSIX thread. P stands for the POSIX threads. POSIX. POSIX. Okay, POSIX threads. You create a thread T, and here actually the thread has created. And while creating the thread, few things has to be passed here. What are those things? I am explaining now how you can create a small thread. So what is? So let's take, there is a void star F1, this void and star, and this function's work is to print ABC. Yes, printf ABC. Okay, you have written this, and after that you have written null. Yes, so there is an int main, and inside the int main we have to create a p thread underscore t, that is t1, and how to create it? The t1 equal to p thread underscore create, and inside the create we have to pass 4 parameters. Okay, so what are those parameters? So first parameter is called as the where to store, that is in t1. Okay, the second one is called as the thread attribute. Currently we are not using thread attributes, so here you have to pass it is null, and here you have to pass the function. Our function is f1, and if any function takes an argument, you have to pass this argument here. Okay, just by writing this much it will create it. What it do? It will create a new thread. So give the name to this t1, this function, and this thread's work is what? Whatever written inside f1. So the moment you write down this f1 means this thread's job is to execute this f1. So if I create a one more thread like t2, so let's take it is sorry, it is not required this. So you have to pass a p thread create, then ampersand t2 comma, then you have to make it is null because we don't require any thread attribute currently. Then you have to make a same f1, and since I'm not passing any argument, I have to pass here null. Then what happens? There are 3 processes currently created. One process which is executing these lines, and here you have created 2 threads, that is f1 and t1 and t2, and both t1s and t2's work is to execute this f1. So by this way you can create it and it will run simultaneously. I'll just modify this program and doing it quickly so that you can understand.
Sir,
1 minute.
what is that thread argument?
Thread argument, I'll show you here. Thread attribute, not argument. I'm saying. What is that argument? No. Argument is this one. Attribute. The thread attribute is basically what kind of thread it is, which kind of scheduling algorithm is using. If it has any priority, then what is the priority? Because when n number of threads gets created, then they may be run in a particular scheduling algorithm. So which kind of scheduling algorithm is followed, that you can also pass it here. But since we are not passing any specific scheduling algorithm, we are taking the default one. So currently you assume that we have to pass it null. Yes, okay. And this is my function which has to be called, and this is the argument which you are going to pass. Then you can say, sir, why argument you are passing? Sometimes we need, I want to calculate a plus b summation. Then what to do? I have to pass this a plus b to this structure. Then only you can do it. So what you have to do? How can you pass this a plus b? Because it is only taking one argument. But you are saying I have to pass a plus b. Then what to do? You make a structure. Inside the structure, you create 2 variables. write the A equal to something, B equal to something, then when you pass this structure's address, then indirectly he is receiving the two things or not. That's why you are passing like this. Okay, so how you are creating, I'll just show you one second so that you can get interest. So first I create a T1, comma T2. The way you have studied, T1, T2. What is your function then? Let's take this. What you are passing, sir, I don't know. So what you have to argument pass? Sir, argument कुछ नहीं था, sir, null pass कर दीजिए ना, हो गया. Yes, there is T1 and T2. We don't require any for loop. इसको भी हटा दीजिए. So we don't require. We don't require this one. So इसको भी हटा दीजिए. So हमारा simple एक thing has to be done. Then what is this? This is our T1. Yes, so that you can understand. So one more thread you are going to create. This is Control C and Control B. So this is our T2. So what happens now? Two threads created, and both threads work is to execute this printf, and I will write some simple printf statement rather than a big printf. Yes, so this printf's work is to printf. This
It is also returning something. This
return something. Yes. To whom? Return to whom? Since a parent has created this thread, the parent has to know that how he has filled.
Oh.
Yes, for that reason it is a return exit. Means what way that thread gets died. Okay, it is not normal return, rather you can find that a p thread exit now. Means he has dead by now. Yes.
Okay, sir.
So this is a n, this is this. So I'll create the output. Yes. So this is my program. I have created A and B, and this will be displayed, and here also it is displaying main terminates. So how many processes? 3 processes. So can you tell me what should be the output of this program? Quick. What should be the output of this program? Yes, quick. This is print hello, and what is the function of this thread? Print hello. This thread's print hello, and this is
AB in any order.
AB will be 2 times or 1 time? 2 times.
Sir, 2 times.
2 times, but in any order. It may be A, B, B, it may be AB, AB, and along with this main terminates. Yes or no? Because here also he is saying the main has to be also displayed. So this can be also fast display, or this will be fast display. There is no such sequence. It has to be run. Okay.
Correct.
So how you can run it? 1 minute, please. I'll just save as with desktop. I'll run once with you so that you can know. So how to run it also you have to know. So you are going to desktop, cd dit. We have a thread 3. To run it, you have to write like this: gcc, then thread 3.c minus lp thread. Okay. Okay, like this. Like a math, when you are using math library, you are writing minus lm not.
Yes,
Similarly, when you are using this thread library, you have to write lp thread. Now it is perfect. Then you run /a.out. Yes.
So the header the same.
Header files are this p thread only.
Okay, sir.
Okay, and other things are set. So now you can see AB has a display 2 times, AB has a display 2 times, and doing like this. Now you can understand, sir, ये तो पूरा sequential हो गया. आपको कैसे पता चला कि ये इधर-उधर करके display कर रहे हैं? You put in a loop, then you can understand that how many times this A and B gets displayed. Okay, A will be displayed, B will be displayed in any sequence. Like if I'll put here a for loop, so take a int I, and I'll make a for that I equal to 0. Okay, I equal to 0, then I should be less than, let's take 100, then it is become I plus plus. Sorry. So start the curly bracket and end the curly bracket. Yes. So if you run this, then one thread has to be run AB 100 times, another thread has to be done AB 100 times. Okay, and this has to be main terminates. So these are not a normal function call. I'll also check with a normal function call and how it is happening so that you can distinguish by this. So when you go to this, then you run this program, GCC this, run, then you run this by ./a.out. Now you can see there is a different, how many times I've run? I make I plus plus. Ah, very interesting, very interesting, very interesting. I plus plus. Why it is displaying AB this many times? It should be 100 times, no? And you're getting I is I equal to 0. I should be less than 100 and I plus plus. Then it is a AB and a this.
सर वो मेन टर्मिनेट हो गया इसलिए
हाँ?
सर वो मेन टर्मिनेट हो गया
That main has terminated. That main has terminated at which point? Here. But after that also running, no? Not because of this. And here also one interesting thing. This main has terminated prior to this processes. But do you think that if it is happening in case of normal function call, can your main will be terminated before this?
No, sir.
Never. Means from this we can understand that these two and this are running simultaneously. So which one will be first run, which one will be next run, that we don't have any idea. But both are running simultaneously. Okay. So from this figure, at least you can know that my main has terminated before his thread gets terminated. So that's the reason you can find that all three things are running simultaneously. Yes.
Sir, if the threads are based on the parent process and if parent dies, sir, here it is creating zombie. But sir, this thread is going to the init process, na?
No. Here what happens now, if the thread will be die, obviously, thread will go to the init process. But what happens here, when a thread parents get terminated, the parent should not be terminated in case of thread. Why? The necessity is that the parent is, threads are using the parent's address space. If parent is going to be terminated, what about the thread's address space? The thread's address space is not proper. So that's the reason what is, there is another function you can able to find, that is a pthread join. So what is the pthread join's work? Later you can study. Pthread join work is, if the parent wants to wait for the child to be terminated, then instead of directly terminating the parent, here you have to write down the pthread join. So if you make a pthread join, then all these processes will be wait for this thread to be joined. Okay?
Yes, sir.
Yes. So this is the way by which you are creating the threads.
Sir,
Now, ask.
can you go to that code?
Yes, I am in it.
Sir, I've seen that in every example of fork, when you have taught that the fork topic, you have always taken I outside the loop.
I outside the loop?
Yes, sir. Any reason for that, sir?
No. My practice is always, I never write inside the for loop this. Oh, sorry. Not an issue. This is it may be my bad habit. Yes, not because of that.
Okay, sir.
There is no such issue is there. Okay, fine.
Okay, sir.
But one thing you can observe here, one thing is, suppose I am taking a int p is equal to 0. Then if I make a p plus plus, yes, and I want to display the here printf p. Now you can know whether they are using the same P or the different P. Yes. Now I'm running this. Are you getting my point? Here I have taken P0. This is a global variable. We know that the global variable belongs to the first parent process. Since my threads are created, the threads are using the child's address space. So this global variable is also used by the child. So if the child is incrementing this P plus plus, means he has to get some data here also. Okay. So let's see whether it is executing in that manner or not. Then I'll listen to your question.
But we cannot tell what the value will be. No?
We cannot take.
So we cannot tell what the value will be because it can be increased many number of times or nothing because the parent is not waiting.
Parent is not waiting. Yes, that is correct. I am saying that all are using the same P or not. That is my point. This all has to be used the same P or not.
Oh.
Yes, that I am basically saying. If you can look into it, this P, and this threads P will be same. And one more query may come. Do you think that this P has to be properly added for 100 and 100 times, total 200 times, or there may be some mismatching? Because the thread is executing this P for 100 times plus. This another thread is also executing this P for 100 times plus. Now, can you say that both will be executed 200 times, means the result has to become 200 times, or there is a mistake also?
The mistake also.
There is a mistake. So we have studied one topic like at the very beginning, that is called as the synchronization among the processes. Yes, why it is happening? When this P is used by a P1 as well as T1 and a T2, this data may not be properly incremented. So that's the reason what you need basically, we need that this area to be synchronized. So we'll study during the process synchronization. Yes, but the basic idea is that there is a common P and both P1 and T1 and T2 are used. Okay, that's the idea. So next, so there are two kinds of threads.
Sir, why, sir, I won't go till 100, sir?
Why?
That AB will not print like 200 times.
Why it will not print 200 times? Oh, very nice. Suppose it is a equal to 5. Okay, there are two threads, T1 and T2. How this plus plus has incremented? You can say that move A comma X. Then you have done here. Then AD X comma 1. Then move X comma A. Is the correct code for incrementation? Am I correct? A को X में भेज दिया, X को 1 increment add कर दिया, then that X has to be saved to the A. The same thing will be written here. Move A comma X, add Ax comma 1, then move Ax comma A. Yes, please tell me if these two codes will be run simultaneously one time, can you tell that the result has to become 7 or change?
Change. It can refer to the previous answer.
Because we have studied one class, we have studied, suppose first it is run, then 5 will be copied, then it's start में Ax में 5 रहेगा, then the context switching is happening. When the context switching is happening, this A is still 5 because it is a global variable, it is still 5. Then this 5 is again copied to 1. He is Ax. Then he is coming here. Then Ax plus 1 changed to 6. So his area goes to 6. When he is returning back, his Ax is also 5. 5 plus 1, 6. Then total how many times it has incremented? 2 times incremented. But actually the result is what? Still becomes 6. Yes? Since it is happening here, then obviously 100 times जब करेंगे वो वही होगा कि नहीं? Because these codes and these codes are running simultaneously. When it will not happen, if my A++ is run by a single instruction, then it will not happen. Why? Because either this is A++ or this A++. When this A++ will occur, then my A has incremented. When this A++ is occurred, this A has incremented. In that scenario, no problem will occur. Means after completion of this, if this code will be started, exactly you can get 7. But if partially it is a switching from one code to another code, then you cannot get 7. Rather, you may get 6, sometimes 7. That's it. So that's the reason we are utilizing this synchronization. Okay.
Sir, but this different threads will have different stacks, na, sir. So why there will be a confusion, sir?
My stack is this. My stack is this. I have shown you. These are the two different stacks. But when he is taking this pipe from this global variable, this, he has a store inside the register. Yes or no? He has to be stored first in the register. And when it is making a context switching, his register's value will be copied into his own stack. Why it is? Because you are not using a global local variable. If you are using a local variable, the result will be 7 and 7. Is your P is a local variable here? No. Your I is a local variable. The P is not a local variable. Since P is not a local variable, that's the reason what happens. In this scenario, they are using the global, store it in the local stack. He is also using a global, store it in the local stack. And when both of them are receiving 5 and kept in the local stack, when they will be incremented, they will get to 6 only. There is no question of 7. Then that 6 will be updated to A. His 6 also updated to this global A. Then ultimately, what is updated in the A? 6 rather than 7. Got it or not?
सर बट वो प्रोग्राम में सर आई यूज करें वो तो लोकल है ना सर.
आई क्या बोलता है? आई बोल रहा है कि हाउ मेनी टाइम्स इट इज रनिंग दिस लूप. Am I correct or not? I is simply saying that how many times this loop is running. But can your I is saying that how many times P++ will run? Yes, you can say yes, sir. Why you are saying no? Sir, P++ will be run 100 times by T1, 100 times by T2. But this P++ may not be a single statement. That P++ be a 3 consecutive statement. And when this 3 consecutive statement will be run by the CPU for 2 different threads, that's why the inconsistency comes into it.
Sir, but sir, in that loop, sir, AB should be printed like 200 times, at least. Sir,
it is not also yes. That also you have to find out because that time nobody has told. If you can look into it, how many times it has displayed? Just 1 minute. Huh? Copy. Huh? I'm just paste it here so that you can understand. No, here only I'll paste. Only 80 times. How many? Here one BA are continuously displayed. But if you can look into it, there is 160 times. 80 times it has run. Then what is the problem? Why it is going for 80 times? Because it has display A to total is 160. 160 means almost 80 times it is going to be displayed. And what is the reason behind this? Why it has less? That time I have asked, but nobody has answered me. Yes, I have run this. It is I equal to 0. I is less than 10 less than. Itna kyun lenge? Oh, 10 lenge. This is 10 and it is I plus plus. This is A, this is B, and this is become P plus plus. And we know that this loop will be run for exactly 10 times. So if you run this program, once again I am showing you. Please carefully look into it. As I run this. Now it is showing something A is displayed 1, 2, 3, 4 times. 4 times. And B has a display 1, 2, 3, 4 times. Total is 4 times. What's the reason? See, look into it. This is displaying something A, and this A, and something is displaying B, and this B, and this B, and this B. Forget about this. Suppose one एक को हटा देते हैं अभी भी. And I am running this. Now, see, it is running 10 times A, B, C, D, something 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Exactly, it will be displayed 20 times.
Sir, then printf buffer.
Yes. When I'm making it is in B, it is not adding. So forget about B also. B को हटा दिए. फिर भी आप देखिएगा यहाँ पर जो P plus plus जो किए हैं, the P is still become 0. It is still become 0. It has not also incremented. But it has to be incremented because I told that the P is a global variable. Sir, आप ही बोले थे P is a global variable and this P has incremented many times. Since P has incremented many times, then it has to be changed. But still P becomes 0. Yes. So 3 reasons you have to tell me that why P is 0, how to get exactly P should be 10 plus 10, 20, how to get it. And at the same time, this A will be displayed now 10, 10, 20 times. But when I'm writing this B, it is become what? Some 18 times or 10 times or 4 times. Why it is 10 times? That answer I will get from you. Yes, but I have just shown that this process running simultaneously. And I also told that this P is a common variable which is executed by T1, T2 as well as this P process. Yes.
Sir, if we place the B in that single printf A/n B/n.
If I do here AB and slash n, this you are saying?
Yes, sir.
That also you see.
No. So that A/n B/n.
Oh, that no meaning at all. Not a very big thing. Yes. It is somehow 20, 20, 40 times.
Sir, I guess
Properly
that two printf is having error.
If you make another print separately, then it is showing some less number of head. What is the reason? You have to tell. Yes.
Sir,
Like I have given an example. Like I have given an example already. The simple example you may think of this one. Because it is not at all properly synchronized. If that printf, this printf is using some common area internally, then it will not. It will always gives you a wrong result. Because the main difficulties of the threading is that unless until you synchronize this area properly, the running thread is not so easy. It will be go in a random manner. Okay, that is one. So next class you have to answer me this. I've given you 3 things. Why there is a P is 0 at the end, how to avoid this. Second question I asked that if there is a 2 printf, then why it is displaying less. Yes, we'll go a little further if you don't mind. Because no, I don't have any issue.
Sir, in the man page it is showing that printf is a thread safety.
Printf is a thread safety. If it is a printf is a thread safety, then why 2 printf is giving you less slack? That is my question. That is my question. Okay, so now come to this. There are 2 kinds of threads are basically used. The threads are basically 2 types. One is called the user thread, and there is a kernel thread. This is very, very important point. Kernel thread. So what is the user thread and what is the kernel thread? The user thread means in the user space, the threads are created. Whereas in case of a kernel case, the kernel space, the threads are created. Then why the user space, the thread needs to be created and where you can feel like this. If you learn this Java programming language, in the Java there is a thread chapter. In this thread chapter, the Java is a programming language which is running in the user mode. And the Java program itself is creating this thread rather than that thread is created at the kernel space. Then what is the purpose of this? When a Java program, suppose you have written a.java and that program is going to create two threads, then this program itself is one process, P1. And for the kernel, the P1 is a process. But under this process, I can create a T1, I can create a T2, I can create a T3. And this T1, T2, T3 are the user level threads. Means it is not directly handled by my kernel. Rather, the programming language itself managing these threads. So the user level threads are managed by the programming language. Managed by programming language. Then what is the advantage and the disadvantage? The first is the advantage. Since my programming language is supporting these threads, that's why for every process they maintain a thread queue. Thread queue means out of these three threads, which one will we get a chance now? That decision is not taken by my OS. Rather, the programming language supports some scheduling or thread scheduling by which among T1 and T2 and T3, which one will be first executed, how much time it will be executed, next T1 or T3, that decision will be taken by the programming language itself. And another advantage is what? Since my programming language creates a process and under that process he himself creating the multiple threads, the context switching time is quite less. You can say no context switching occurs. So first part I told, it is maintaining a thread queue. The scheduling has to be done at the user level only or by the programming language itself. And among these three threads, when one thread will be created for the execution, that decision itself is also taken by the programming language. That is not taken by our own process, as our operating system does not take. Now, think come into picture. Suppose you have created a.java, you have created a b.java, you have created a c.java. For a.java, this is P1 process. For b.java, this is a P2 process. For c.java, for the P3 process. For my CPU or for my operating system, these are only three processes are running here. But as for the programming language concerned, under P1 there are three threads. Under P2 there may be another T4 and T5. Under P3 there may be two more or three more threads are present. So the programming language knows that indirectly he is running now 7 threads. But for the CPU, it is running only 3 processes because these threads are not visible to the OS. Rather, it is visible to the programming language itself. That's why what they're saying, even if a scheduling algorithm is applied by the programming language, but in the same way that may not be run. What is the reason? The reason is the way the programming language fills this T1, T2 and T3, the same way the CPU should not treat him. Because the CPU has also other processes. When T1, which is the highest priority of A.java, when T4 is the highest priority of this B.java, when T7 is the highest priority of this C.java, but when these three things will become here for CPU, these are the normal portion. Like when these are the different colleges, assume, and they are sending the best player to the university tournament. Then when this player, and this player, who is the best in those colleges, when it comes here, but my team, the university team, treat him as a normal player. Because for him, these are the normal processes. And for these processes, the CPU or the operating system assigning the different priority. That's why these are basically the user level threads where the no context switching is required because it is managed by the process itself. They are using their own ready queue and they are use their own scheduling algorithm to perform it. Okay, but what about this kernel thread? The kernel thread is acting like a normal process. Acts like a normal process. Yes, normal process. What is the purpose of this kernel threads? The purpose of this kernel thread is that when a user process comes for the running, the user process cannot directly run by the CPU. Rather, a kernel thread will be accept a user process, and this kernel thread, another kernel thread will be managed by this CPU. Means every kernel thread handling some user processes or the user threads, and those kernel threads are basically the processes which is executed by the CPUs. So therefore, the every process running at the user mode is not directly accessible by the CPU, rather it is managed by a kernel thread and do it. Now the next question comes, if there is a n number of user processes, is there any n number of kernel threads? May not be, because there are three criteria they are using: a one-to-one, one-to-many, many-to-one, and many-to-many. What it does, one single K will be managing one, that is U. In this case, one single K may be managed with different U1, U2, U3. There are many kernel threads, that is K1, K2, and K3. The same user process U sometimes comes here, sometimes executed here, sometimes executed by this. This is many-to-one. And what is many-to-many? There may be many kernel processes. There may be many user threads. They are changed from one to another. It is not at all fixed. Yes. Then what you have understood here? Every time when a programming language runs a particular program, that becomes my user process. And the user process may create a multiple threads, but that thread is not visible to this kernel space. Rather, the whole threads belongs to a particular process, will be thought of as a single process for this CPU. And when we receive it, then which thread will be running? That decision has to be taken by the scheduler which is present at the user level. But there is a kernel scheduler and there is a user scheduler. The user scheduler takes a decision, then which thread among these three will get a chance to be entered. But for this kernel, he knows that I am executing P1. Whether T1 comes or T2 comes or T3 comes, still he feels that I am executing P1. That's why one biggest difficulties comes, even if it looks very nice as per the user's perspective. The biggest difficulty is that, assume this T2 requires some IO, and T1 and T3 does not require any IO. And T1, T2, T3 are the user threads. Do you think that the T1 and the T3 has to be run or not run? Are you getting my point? A particular process A.Java has three threads. These are the user level threads. And when user level threads T1 is running or T2 is running or T3 is running, suppose T1 requires some scanf or some IO, then it is moved to which state? It has to go to the block state. When it is goes to the block state, can your T2 and T3 will be run or not run? Are you hearing what I'm saying?
They must run.
So
Yes,
not
sir, they
run.
must run.
It will not run. Why? Because from the CPU point of view, I am running a P1 processes. When T1 has come, who has sent? There is a scheduler here who will send this T1. When the T1 will be sent to this particular P1, then the P1 will receive this T1 and give it to the CPU. While running in the CPU knows that he demands one scanf. Then he send it to the block state. So he is sending the block state to whom? To P1 or to T1? To P1.
Oh, P1.
Are you getting my point? To P1 means the whole P1 becomes block. So because of the P1 blocks, even if T2 and T3 does not require anything, still it is not. So that is very.
Sir, but if another kernel thread can be assigned.
Another kernel thread?
So another kernel thread can be assigned to
Very,
the
very nice. I understood that. What you are saying, another kernel thread will be assigned for whom?
T2 and T3.
But do you think that there is a two states at a time present for a particular P1?
Hmm.
Never know. Because for P1, one PCB has created. And we know that this PCB has a one parameter called as a thread, process state. If it is a process state already set to block, do you think that it will be changed to one place it is showing that it is blocked, another place it has to be showing that it is ready? Never know.
Okay, sir.
Yes, that's right. It's not happening. And one more interesting part, if I'll ask. So the two things, sir. Suppose the two threads are belongs to a same process. Context switching will be faster or slower? Two threads belongs to the same process. Then the context switching will be faster or slower?
Sir, faster.
Faster. Means in case of thread, the context switching is faster. But please remember, if two threads are belongs to two different processes, in that case the context switching will be faster or slower?
Slower.
Slower. Means if it is a P1 process and if it is a T1 thread and it is a P2 process and it is a T2 thread, the context switching between P1 and P2 is same as T1 and T2. But if the P1 has a two threads like T1 and a T2, then the context switching will be very fast. Okay, that's why the two views they are giving. Even if the kernel threads are belongs to the processes, but if the kernel threads belongs to the same process, then the context switching will be faster. If the kernel threads belongs to the two different processes, then the context switching will be similar to the previous one. Okay, so by this way, we can know the kernel threads are necessary to execute the user processes, but the user threads has some advantages. The biggest advantage is that the responsibility of the user threads is not taken care by our kernel. Rather, the programming level, at the programming level itself, those threads gets managed. Since at the programming level those threads are managed, the way the priority given to those threads by the programming language may not be maintained in the same way by the kernel processes. Okay, so it has some advantage and disadvantage, but any programming language, if you can find like your Java and other languages, when they are supporting the thread, basically they are supporting the user thread. आप देखिएगा जब जावा में थ्रेड चैप्टर आप पढ़ोगे, जब आप प्रायोरिटी देके इसको सेट करोगे and you are running, you may not find in the same result. What is the reason? The reason is that you set by Java, you set the priority will be 20, but when it is come here, he is setting the priority of a P1, not of T1, because for him it is not visible at all. For him, he knows that P1 is just a process. Okay, that's it. So this is about the simple thread chapter. The thread is a huge one, but few things you have understood how the thread is running parallelly, and what are the two different kinds of thread. And one disadvantage you have studied in the user level thread is that if our user level threads is blocked, then that thread belongs to which process? That processes all other threads is also getting blocked, because the kernel level has blocked the processes rather than the particular thread. Okay, so next class will start with the interesting topic, which is numericals, that is called as the CPU schedule. I thought about today I'll start, no problem.
Sir,
We'll go there faster.
sir, can you copy paste that code into the chat, sir?
Copy paste that code, why not? I'll make now I'll copy. Before come to the next class, please prepare this. You have to tell me what happens. But how can you avoid and how can you make AB should be displayed 20 times? If you can think also, that will be good. I'll put it in the chart now. Oh, sorry.
Sir, you can upload a file also there.
Ah.
Not required of copy paste.
Okay. I don't know. I've just sent it. If you can do it, it's okay. Okay. I've sent it. So many up to fork everybody has tested. Fork case. All forks? No, not it.
Yes, sir.
Okay, done.
Then a
Now
lab
thread.
I'm talking about.
No, not lab. In the
Yes, sir.
lab actually, one more. Time is over. Next class I'll give you assignment. You just ask me, sir, give one assignment related to cell scripting. Okay. I have kept one real environment assignment. Yesterday, my one sessional was there, C programming. There are around 300 students. I collect all the files. They have uploaded the files in the Moodle. I downloaded those files, but 2 times they have submitted. Few people have submitted in one link. Few people have submitted in another link. Few people have submitted in both the links. You have to write an shell scripting by which you create automatically for each individual student one folder, and under that folder the unique files from the 3 different uploading has to be come to one. मीन्स कभी कभी होता है ना, आप लोग जब एग्जाम में सबमिट करते हो, पहला टाइम में जो दिया जाता है आप एक बार सबमिट कर देते हो, फिर टाइम में बचा नहीं, फिर आप कंप्लेन करते हो, फिर और एक लिंक को खोल देते हैं, फिर कुछ लोग वहां पे सबमिट कर देते हैं. ऐसा भी हो सकता है कि वहां पर जो सबमिट किए हैं वो डुप्लीकेट भी कोई किए हैं, कोई जो पहले नहीं किए थे वो भी किए हैं, जो पहले किए थे वो भी किए हैं. Then you will get these 2 different folders where all the files will be present related to the roll numbers and how to segregate it.
सर वो शेल स्क्रिप्टिंग कैसा होगा वो?
पूरा शेल स्क्रिप्टिंग हम तो लिख रहे हैं, कल लिखे थे, हम बताऊंगा सर.
ओके सर.
ओके फाइन, आई एम एंडिंग नाउ.
सर
हाँ
सर, वो कोड कॉपी नहीं हो रहा जूम का चैट से, आप मेल पे भेज देंगे थोड़ा?
मैं वही मेल पे भेज दूंगा आप लोग को, होगा ना, तुरंत भेज दूंगा. एंडिंग द मीटिंग. थैंक यू.
थैंक यू सर.